Composite functions. So that's f of g of x or g of f of x. That's a function inside of a function. It's a decision inside of a decision. You can't make the outside decision until you make the inside decision. So in this case, with f of g of x, that's f again with g of x inside. So g of x is the inside function. G of f of x is g with f of x inside. For example, given f of x is 1 over x squared minus 4, and g of x is the square root of x plus 5, we're going to do 4 examples here, starting with f of g of 4. That means we first need to find g of 4. We're going to plug in a 4 for x into the g of x equation. If we do that, we get the square root of 4 plus 5, square root of 9 is going to be 3. And now we're finding f of 3. Plug a 3 in for f of x. 1 over 3 squared minus 4 will be 1 over 9 minus 4, or 1/5. Next up, let's do g of f of 0. That's g with f of 0 inside. Plug in a 0 for f, and you'll get negative 1/4. Now plug negative 1/4 in for x for g of x, and you'll get the square root of, this one's kind of fun, negative 1/4 plus 5. Ooh, well, common denominator would be 4 over 4. So it's negative 1/4 plus 24, so it's going to be the square root of 19/4. Can't take the square root of 19, but you can take the square root of 4, so it'll be the square root of 19 over 2. Next up, f of g of 2. So it's f with g of 2 inside. Now, if you plug in a 2 for g of x, you'll get the square root of 7, which is fine, because now we're going to do f of the square root of 7. 1 over the square root of 7 squared, so that's going to be 7. So 1 over 7 minus 4 is going to give you 1/3. And then lastly, g of 11. That's g of 11 inside. So plug in 11. 11 plus 5 is 16. The square root of 16 is 4. But now we have g of 4. Do it again. 4 plus 5 is 9. And the square root of 9 is 3. Other than that, you may be asked to find the domain after dealing with a composite function. And when you do so, you need to combine the domains of the inside function and the final composite function. For example, find f of g of x and its domain. That's f with g of x inside. G of x is the square root of x plus 5 in this question. So you're plugging that in for every x in f of x. That'll give you 1 over the square root of x plus 5 squared minus 4. Well, the square root squared will just leave you with x plus 5 here, minus 4 on the denominator, leaving you with 1 over x plus 1. Now for domain, the inner function. Anything inside of a square root has got to be greater than or equal to 0, so therefore x is greater than or equal to negative 5. The final composite function, a denominator cannot equal 0, so therefore x cannot equal negative 1. Put that together, greater than or equal to negative 5, but not equal to negative 1 will give you the final interval notation. Now I'm done, but I know some of you might look at this and go, wait a second. 1 over x squared minus 4, back in the beginning here, there's a denominator right there, and if I set that equal to 0, you might go, well, x can equal 2 or negative 2, and I see both of those would exist in this answer. So what's up? What's going on? Why don't I include those? Well, it's because you're not plugging directly into f of x. You're doing g of x first, and from g of x, you're plugging into f of x. But if you're concerned, you can go ahead and try and plug those into the composite function to check. And by the way, I already did that right here. If you noticed, I did plug in a 2, and it did work for f of g of 2. So again, we're considering the domain of a composite function. It's the inside function, the final composite function when dealing with domain for f of g of x, g of f of x, or whatever composite function you encounter.